A couple of times the discussion's touched on discipline boundaries, and one often hears the view these days that progress is hampered by the sort of siloed nature of our disciplines, and that all the really interesting breakthroughs in the future are going to be interdisciplinary and so on. I'd be interested in the panel's views on that proposition, and if it's true, what are the implications for training? Should we still be training chemists, or should we be encouraging students to learn a bit of chemistry, a bit of biology, a bit of physics, and so on?
Great question. Who wants to go first?
I'll go first on this one. So obviously I work across boundaries quite a lot, anywhere from the engineers to the physicists to the chemists, even to the biologists to the medics. And certainly the barriers I feel are often related to language and the perceptions of what certain words mean. But when it comes to education, so, obviously in our school, in the School of Chemistry, we have a chemistry degree, we have a medicinal chemistry degree, we have a nanotechnology degree. And so obviously the nanotechnology degree, which is reasonably unique in our campus in that it started with materials, physics, and chemistry and biology all planning the degree together. And what you do is create a different student. And the students, relative to the chemistry students, are exceedingly different in that they're often the way the work is taught from the problem first, and then what you need to know to solve the problem. And that creates, with the nano degree, that is distinct from the traditional way we teach chemistry, where we start with, I think, an inherently you're meant to be interested in the subject, so we start from the bottom and we start building up in complexity. And those two types of students together are very powerful working in a team, because the nano students will go out and try anything, often not really knowing much depth on anything because they've got more breadth. The chemists sit there and then work through it. So I don't know what the solution is, but I still feel that depth and then the courage to go out from depth is the model that I would prefer.
Interesting here, Andrew's view from the Melbourne model. Maybe
well, no, I won't speak. The Melbourne model is basically the Bologna Model. But I think, personally, I would value not abandoning the core disciplines in training. I think it's really important to start with the core discipline. But then, from then on, I think it's open slather, and one should be teaching people to ask incisive questions and questions that will lead to meaningful understanding. So, but I think it's quite hard if one abandons the core training.
Yeah, I agree.
Oh, I totally agree. I believe we need the core degrees. Getting across education prior to coming to universities, I think these days a lot of people stay away from some of the physics, chemistries, and then find out when they come to university they need them, and they've missed out on something really good that could help them. So I think getting a broad education earlier on is good, but I think we really need the core disciplines and learning it that way. I mean, not to say that the nanotechnology brand is not a bad one.
I think we're all making the same point. Yeah. I think the difference is the courage, right? Mm-hmm. We've got to have the courage to go out and go across the boundaries.
Yeah. And which is why, in a way, sort of getting students to actually go outside that comfort zone. So yes, you can have a student in chemistry, but perhaps if you're looking at the opportunity to go off and do an honors thesis in collaboration with, other discipline areas, so you almost sort of make that as a requirement, if you wish, and say, your job is to, go off and define your honors thesis in a way that you can bring in some of these other discipline areas into your honors thesis. Maybe a nice way to kind of push them outside that comfort zone.
I think I know from many of the labs who work in, let's say, interdisciplinary areas, and I think George Lab perhaps is an example for this. You hire biologists, you hire mathematicians, computer scientists into your group, and if you have really very well educated people in their specific disciplines and make them talk to each other, I think that's the better way forward than just have some jack of all trade chemists there who think he can do the whole range of things. I think is that right, George? Or is
but the one remark that I would make is that I think that every scientist, more or less regardless, should know Maxwell's equations, quantum mechanics, statistical mechanics, thermodynamics, the basics of metabolism, the basics of higher mathematics. You know, by higher, I mean not really complicated stuff, but linear algebra and differential equations and things like that. It's very hard, it turns out, to learn more mathematical stuff as you get older, either because you don't have the time or you don't have the motivation. And even subjects that are, you would think, pretty straightforward, one being statistics and probability, but particularly statistics, is so important, and generally we scientists know it so badly that it becomes almost a religious incantation to justify bad behavior. And it's known in the trade as p-hacking if you're in this business. And so you really need to know that stuff and know it really, really well, and then you need other stuff on top. But I mean, I'm all for hiring experts in X, Y, and Z, but partially to act as teachers, not just act as hired experts.